Welcome back to the workshop. So I think in the last video I said that we'd move on to the final drive shaft fix. Well, that was the intention, the final drive shaft fix being just getting the required length of drive shaft so I could send them off to get machined up. But whilst setting up for that little job, I've come across something that requires our attention. As you can see, we've put the suspension on, including the wheel, so we could set the rear suspension to ride height and get a good idea of how long our drive shafts needed to be. But whilst I was doing that, I noticed this. That is an unacceptable amount of movement. So what the hell is going on? Well, there's nothing wrong with the fit between the bearing and the upright. That pressed in fine and there's absolutely no movement between those two parts. There's nothing wrong with the fit between the hub and the inner race of the bearing. That's the bearings that hub was designed around, and that pressed in fine as well. No movement there. All of that movement is coming from inside the bearing. I had bought good quality, or what I thought was good quality SKF bearings so we wouldn't run into issues like this. And to make sure the inner races were preloaded enough, we grabbed this tiny little rattle gun, which is good for 1.21 gigawatts of torque, and the thing's still flopping around in the breeze. Not happy. So after a lot of investigation, it looks like this might be a pretty common issue with this type of bearing, which is effectively two angular contact bearings in a single outer case. These bearings are really good and they're used in all sorts of things like machine spindles and stuff like that, but when they are used in those sort of high performance / high accuracy applications, they are usually used as two separate angular contact bearings back to back, and then they're a matched pair. So the faces are ground down, either the inner or the outer, to provide exactly the right amount of preload on each bearing to remove any of that axial movement. Unfortunately, they don't make singular angular contact bearings of the size we need, which is 42 inner and a 82 outer. It jumps from 42 to 45. So we're stuck with this automotive style dual angular contact bearing. So the plan is to pull the upright off the car, strip it down, push the hub out of the bearing. This inner race will come off with the hub. Then we'll pull this off the hub, make a jig for it, put it in the lathe and try and grind off just enough material off the back of the inner of the bearing to allow the preload to remove any of that free play. This is going to be a dangerous job. So I've got a baseline. I've set the upright up in the press to preload the inner races. So this should be as installed. And we have around 1.15 mil of movement in that bearing. Ridiculous. This is probably the scariest part. I really don't want to damage the upright. So you can see I've spent a bit of time and made up a jig to hold it in the press. Then I'll spray some Loctite freeze and release up inside the hub. That will do absolutely nothing, just makes me feel better. Don't know what I was worried about. Next we want to carefully take our balls out, which is, just good advice generally. And now we need to remove this inner race from the hub without damaging it. It's not as dodgy as it looks. That's annoying. I chipped the inner race somehow when I pressed it off. So it looks like I'll have to order a new bearing. So I've got another bearing, SKF again. I got it through a proper dealer this time, just in case the other ones were replicas. And it's even worse. Over 0.2 of a millimetre of free play in the bearing. Carry on with the fix. Before we attempt the fix, we'll just take a reference reading of the width of the inner race. This is the section of the race that we will endeavour to remove some material from. And we are at 18.03 millimetres. Remember that. Welcome to my homemade cylindrical grinder. Yes, that is a Dremel. It's got a grinding stone on it, and I have mounted it on a quick change tool post with a rather large tube clamp welded to a bit of RHS. So the inner race has this pressed metal shield attached to it, which makes it quite tricky to hold. To get around that, I've machined up this arbor to mount the inner race on. This, because I've machined it and have left it in the chuck, it's very concentric, which isn't such a big deal, but it means that this face is very, very perpendicular to the direction of rotation, and that is critical. There's not going to be a huge amount of force on the race while we're grinding it, but we do need to stop it spinning around. I could have just Loctite it on there or even used some super glue, but I want to be able to take it off, check it, and then put it back on easily. So I've put this little inverted grub screw into the arbor, so we can just slide the bearing race on, and then just a very small tweak of this grub screw. Hardly needs anything at all. And we're ready to go. So it looks like we've taken 0.02 off. Let's see if that's done anything. So with that small amount of material removal, we've already reduced our free play by quite a bit. So I think we'll just do that a few more times and carefully creep up on it. So with nearly 0.1 of a millimetre off that inner race, we are down to almost no movement inside the bearing, and it still spins. Winning! Repacked the bearings with grease, so now I just want to carefully tap the seal back in place. Well, that has worked out entirely too well. Reassembled with the seals both pressed in no problem, and rechecked them in the press, and still no perceivable play, and are not binding up. Totally deserves a beer. Since that worked so well, and I've got the hubs out of the uprights, I thought I'd ruin my day by destroying my hubs, replacing these rage-inducing wheel bolts with a set of proper studs. This knurl diameter is 12.75 millimeters. We want an interference fit of between 0.1 and 0.45 millimeters. This drill, or this drill bit, is some imperial size that equates to 12.3 millimeters, which is right on the outer edge for being too small. However, twist drills rarely drill an accurate hole. So I think I will drill out one of the threads with this drill, we'll measure it and see where it's at. If it's still too small, we'll move up to a 12.5 mil. But if we do that, we're starting to get dangerously close to the hole being too big. So that made a complete liar out of me. It appeared to drill out at exactly 12.3 millimeters, which is too small. So I've stepped up to the 11.5 mil, which should give us 0.25, which is perfect if this drill bit does the same thing. It's another good quality Sutton drill bit, so let's hope. So I've given those holes a good chamfer from the back to make sure that the head of the stud seats correctly. Press it in. Oh, glad I went to the next size up drill. This is when you realise you've put the stud in around the wrong way. So the last thing I want to do to the hubs before we reinstall them is that the edge of the heads gets very, very close to the snout of the upright. So I've turned up a bar in the lathe and bolted the hub to it, and now I just want to machine off a little bit off each head of the stud just to get a little bit more clearance. That deserves a beer. Bolted the rear suspension back together, put the CV joint in and done that up, and feel that? Absolutely perfect. Zero free play in that bearing now, and it spins just as freely as it did before. Maybe a little bit better. So I think that's enough crazy machining for one episode. How about we head over to the welder? This is the front lower suspension arm. I've already modified it a little bit. This plate was originally only 2 mil thick, and I've cut that out and replaced it with a 5 mil thick plate, as the 3 mil plate was already bent, and all the suspension or all the spring loads go through this plate up into the spring and damper assembly. I've assembled it on the car. I've got some new rod ends for the top front arm, and checking it out, it looks like I can sneak another 12 mil of overall track width out of the bottom arms if I move this location out. So the project is to cut this plate out, weld in this new plate, which has been extended by 12 mil, and then I think we'll add a little bit of bracing around it. So with that new bottom arm bolted up and a similar adjustment to the top rod end, we are running around about 3.5 degrees of neg camber at ride height, which is a really good starting point. And now the rod end's in a really good spot, and we've got a bit of adjustment in either direction. So a bit of a short one, but that'll have to do, which is totally what she said. So the rear wheel bearing fix has worked out really nicely. I'm amazed that everyone deals with that amount of free play in those bearings. Maybe I've got a bad bunch of bearings. Maybe I've missed some crucial step, but it's all fixed now. So we can move on. The front suspension change has also worked out nicely. I've already worked out the length of the drive shafts, so they're off getting machined at the moment, and have worked out all the lengths of the new dampers and springs, so I'll be ordering them soon. Not sure what I'll do for the next video. Got a few small jobs. Was thinking about possibly doing a bit of a garage tour, so let me know if you're interested in that. But until then, thanks for watching.